All right. Well, my thanks to InterNACHI for scheduling this webinar, and I admire InterNACHI as a guidance organization, and also what you home inspectors do for a living. It's very important. There are also quite a few energy specialists attending this webinar, so welcome everyone. My purpose in writing this book was to communicate the fundamentals of energy efficiency, comfort, health, safety, and durability for buildings. I created the first edition in 1992. This is the 7th edition with 530 pages and 450 illustrations. I have significantly improved the content of every edition based on what our industry has learned over the years. Most of my readers use this book as a reference. Readers need information about a specific topic, and they find it by going to the table of contents or the index. The book also contains many cross-references for navigation from one topic to another. During the seminar, I will show you many of the illustrations in the book and talk briefly about the topics that these images illustrate. Let's get started. There is a relationship between what you home inspectors do and what energy specialists do. If we energy specialists don't recognize hazards, and if we aren't careful, we can cause all kinds of problems. And you're the ones that are going into homes and searching for the problems and, reporting them. And, the most prominent of these problems for us, and probably for everyone, is indoor air quality and moisture problems. Then there are today's topics specific to energy efficiency, which I think may be a learning experience for you. We're going to include air sealing and insulation, windows, HVAC systems, which I think are very important to be able to identify. And sometimes there are so many different types that it's hard to identify them. And I hope that this will help you. Also, low-cost cooling strategies. Our Earth is getting warmer, and it's getting more difficult to stay cool. So we're going to do that. So I'm going to start off with some images just to get you started. The first chapter is building science, and it just talks about the physics of buildings and about comfort and about energy efficiency and all that kind of stuff. I'm not going to go into that. There's a lot of background information, but there's no more physics or math or anything than what you need to understand energy efficiency. So then the next chapter is, building construction. It's just kind of an overall for your information type of thing. Here, we're showing the types of brick walls. And I think you're probably the same as me. If I look at a brick building, I'm not immediately sure of what kind of a brick building it is, whether it's, wood frame brick veneer, or whether it's spaced double brick or standard double brick. And, this chapter explains a lot of things about wood frame construction and about masonry construction and steel and things like that. And so then let's move on. I want to get one thing out of the way, and this may seem a little strange, but the building codes focus on preventing the spread of fire inside buildings and between them. And this overlaps into home inspection and to energy efficiency work. And a fire barrier is a term with a specific meaning in the building codes. It is a building assembly that has been tested and certified to withstand a certain fire for a particular period of time. Okay, so the first type of fire barrier that we want to talk about is the thermal barrier. And, you know, a lot of people confuse this. They think that insulation is a thermal barrier. Well, no, we don't call insulation that because the codes own this term. A thermal barrier is a material or assembly that protects materials behind it from reaching a temperature of 250 degrees. This is what drywall is all about. It has a 15-minute, it has 15 minutes of fire protection. You know, the codes are focused on preventing fires from spreading. So that's what the thermal barrier does. Then there's something called an ignition barrier, which is a material that protects foam insulation from igniting. And there's a number of different materials that you can use as ignition barriers. The next one is a fire partition. And that's a fire barrier that prevents the spread of the fire between rooms on one level of a building. Then there's a firewall, which is a structural fire barrier between two buildings. Like if you have a bunch of townhouses, you know, connected to one another, in between each townhouse, there's a firewall. You can't change anything in that firewall. You can't be drilling through it. It's kind of a sacred thing that's going to stop a fire in one building from spreading to another. Then there's a fire stop, and I think that's the most interesting for us. And a fire stop is a passive fire barrier that seals openings and joints in a fire-rated assembly or floor assembly. So if you've got some kind of a hole in an assembly, what the code wants you to do is they want you to cover this hole, and they want it to be covered with a solid material and fastened well, so that, you know, that there's not an air passageway through the building where the fire can spread, because fire just loves to get inside these passageways and spread to different parts of the building. Okay, I'm glad that's over with. Okay, here are our friends, the biological particles, because we're talking about health and safety right now. And, you know, when we have condensation, when we have high humidity, you know, that condenses water, and water is what these, what molds with spores, what fungus, what dust mites need to thrive. And these pests, they create spores and different body parts that, you know, people are often allergic to. And so this is one of the reasons why we try to be so careful about solving moisture problems or not causing moisture problems in buildings. Then we've got good old radon, and I'm sure you see, you know, if you live in an area that has a lot of radon in the soil, you'll find sometimes, you know, a radon fan, which exhausts, you know, air coming from the ground to the outside, so that the, you know, radon air, you know, doesn't get into the building. And this is serious, you know. I mean, 20,000 people a year die from lung cancer because of radon. So it's part of, you know, our health and safety chapter. Asbestos, you know, not that dangerous. You know, most of the people who died from asbestos poisoning, you know, were smokers who worked with asbestos every day. But we don't want to touch asbestos. We don't want to take it down. We don't want to touch it, because that's the responsibility of professionals who are licensed, just like you guys are. Okay, so then at the end of this chapter, we have a section where we look at a pollutant. And then the best thing that you can do with a pollutant, let's say that you've got a bunch of chemicals laying around the house, is source control, like get the chemicals out of the house, put them somewhere else, because, they leak, vapors and stuff like that. And it's very bad for your health. So here we have, the first one is ground source moisture. So ground source moisture is, the way a lot of moisture gets into the house. It comes up through the ground, either as liquid water or water vapor. And, it can make a crawl space or a basement very, very humid. And, that's not healthy. So the best solution for that is to control surface water. You want a system of, drainage around the building. You don't want little puddles and, water sitting up against the foundation. And so you want to seal the foundation, and you want to install a crawl space moisture barrier. You want to cover the ground with plastic so that the water vapor and the water can't get in and can't, cause problems. And then, another choice of dealing with some of these pollutants is ventilation. And it works for some pollutants and doesn't work with others. So ventilation can be a partial solution here. And then there's filtration, which we'll talk about a little later. And it has no effect. You can't filter water vapor. So that goes for all these things. And this is one kind of tool that we use to summarize, a chapter. So let's look into moisture management. The behavior of moisture is kind of interesting. You have diffusion and you have air leakage. They're the big two things that bring moisture from the outside to the inside of a house. And if we have a leak here, and if we have a pressure difference, if there's a high pressure on one side of the wall and a low pressure on the other, that pressure will bring the water vapor into the home. And then with vapor diffusion, you have a very dense condition on the outside. The water vapor molecules are very close together, and on the inside they may be far apart. Well, the water vapor is going to want to go through here. And, sometimes we use vapor barriers or vapor retarders to slow down this process of vapor diffusion. And it's not as important as the air leakage. And, if you have a porous building material, the water is, if the water vapor is denser here, it's going to go in here and it's going to be absorbed, by one of the pores. And, as long as, there's just one molecule of water vapor, at a time, bouncing around or landing on something, that's fine. But when you start getting those little pieces of water vapor together, then that's when the water happens. And the water is what the pests need. And so it's a problem when a porous material gets soaked full of water. And so then there's, this is relative humidity and comfort. So there's two types of humidity. There's absolute humidity, which is on this axis. And then we're looking at two air masses, okay? This is the outdoor mass, and it's say 40 degrees and 70% relative humidity. But we're going to let this into the house through an air leak or through ventilation, and we're going to, heat this up to about 70 degrees Fahrenheit. And when we heat it to 70 degrees Fahrenheit, it's only 19% relative humidity, where in the first case, outdoors at 40%, it was 70% relative humidity. So when you raise the temperature of a body of air, you're reducing its relative humidity. And so relative humidity, affects comfort a lot. So if you're between 0 and say 25% relative humidity, that's uncomfortably dry. And you may feel it in your lips and in your mouth and in your nose, and your skin gets real dry, and it's uncomfortably dry. But then, say between 25 and say 65, that can be comfortable. Although we want to avoid this area here that's a little before 60% and a little bit after 60%, because that can easily cause condensation of water, and we want to avoid that at all costs. We do not want these pests colonizing our buildings and eating them. Then we get up to, let's say, 65 degrees to 100% relative humidity, and this is uncomfortably humid. In the summertime, the reason why it's humid is most of the time in the summer, especially if we're moving around, sweat is our leading tool to reject the heat that we need to reject. And if we can't reject the heat that we need to reject, we're going to die. Okay, so it's really, really important to understand this idea of humidity and comfort. And so there's different ways of controlling humidity, and we'll touch on those a little bit later. Okay, moisture sources. This is the kind of thing we do to illustrate, what types of things to look for. If you've got a humidity problem in a home, there's all kinds of things that it could be. It could be water vapor coming up from the ground. It could be from capillary action, where the liquid water itself just climbs up through the dirt, and all kinds of other things, contribute to the amount of water vapor in a home. Now, one of the things we have to think about more now than anything, because there's so darn many floods, is how to direct water away from our buildings, and how to if we can drain that water to somewhere else. Oftentimes in a real flood, that's going to be impossible, because the water's 4 foot deep everywhere. But if you have a situation where sometimes water sits away from your house, or you get a rainstorm and the water comes and actually, leans against your house, I would suggest you think about, doing some landscaping and try to get that drainage done. I don't know what you do about, well, I do know something about what you can do to avoid a flood. You can pick your house up and put it on stilts, that's pretty expensive, but having your house be ruined is also pretty expensive. And then we've got our below grade spaces, our basements and our crawl spaces. And of course, we have a lot of bad problems with them, moisture getting into them. And so sometimes we install submersible sump pumps, and we pump the water out into, a drainage ditch, or we pump it out to daylight, what we call daylight. And what we mean by that is that we pump it to somewhere where it can just run out somewhere, and maybe, go into some kind of drain on the street or something like that. Water management, we got terrible water management here, and we have good water management here. Okay, here we got the ranges coming down on the roof, and there's no overhang, and we can have a puddle here and wet soil here, and there's plumbing leaks inside, and there's roof leaks. And, this is a building that is doomed unless we fix all these things, and we have a housing shortage. We can't afford, to be losing housing to just a lack of maintenance. So we have to, encourage people to do the right thing, to maintain their buildings. Flashing is real important. There's all kinds of moisture barriers that we talk about in this book, and so you can learn more about moisture barriers if you're interested or if you need to know. Let's talk about air leakage. This shows the three most common ways that pressures build up in a house. In this one, you're just heating the house, and the hottest air goes to the top, and it goes out of the air leaks at the top, and that has a tendency to pull outdoor air in through the bottom. So this pressure, it's necessary for there to be air leaks. You can't just have a leak. There's got to be a pressure difference between one side of the leak and the other and make it flow through the leak. And that's what this is all about. These are air leaks as seen through a infrared camera. Okay, so there's areas here and here that you see. That's just those areas transmitting heat through the material. But anything where you see a smearing here, there's a smearing here. It's the dark parts are the parts that are leaking. Okay, the air is leaking in, and it's making this area real cold. But as you get farther away, then it's not quite so cold because it's already deposited some of that coldness, and so infrared scanners are great for finding out all kinds of things about buildings. Moisture problems. Okay, we got the villain of air leakage right here, recessed light fixtures, and the older ones they have holes in them for ventilation because they don't want the fixture to get too hot, and so the warm moist air from the inside during the wintertime comes up through here, and it deposits water condensation here. And that keeps happening year after year after year, and this spot right here gets more softer and softer, and the mold is growing on it, and the mold's having a good time eating this stuff, and it's a really bad situation. And so we can stop this problem by this used to be the way that we did it, most often is we would put, some type of a box, a drywall box around it, and and seal it so, it was airtight. But the best way to do it is just to take the whole fixture out and cover it with this flush fitting LED fixture that covers the hole for the recessed light fixture. And after this fixture is removed. Okay, basements and attics. Sometimes you have these, vertical airflow leaks, all the way down here. This is one big leak on this stairway. And if you were to shine a light in the attic, you could see that light from here. So it connects the whole heated and cooled building to the attic and the crawl space. And the attic is real hot during the summer, and it's colder during the winter, and you're losing all kinds of energy through systems like that. Let's see. We don't need that. Okay, so we have sections like this where we talk about air barriers, a lot of people, including architects and engineers in some cases, don't really understand what an air barrier is and why we need an air barrier and why we need it to be pointed out on the building plans. And so, in modern buildings, they have, we now have standards for an air barrier material, and an air barrier material might be something like, a liquid that you paint onto the, the outside of a building that stops both water and air. And so that would be an air barrier material. And there's a pretty strict standard for that. But as you go to the air barrier assembly, you start assembling things and fastening things together, well, that's going to cause more air leakage. So that's not quite as high a bar. And then the air barrier system is even a lower bar. So this is the kind of things that we do to help people who, think of things in a very scientific way. Also, we talk all about blower door testing and how to do it and what it does and the different standards for blower door testing. Blower door is just a big fan that depressurizes the house, and you take some measurements and then you compare them to the standards. And, really, it's really, really hard to get a house airtight unless you have a blower door, and so this ends up being something that, really the professionals should do. Okay, let's move on to insulation. So a lot of people think that if you compress insulation, that it reduces its, what it does. It reduces its thermal resistance. And in a way that's true, but in a way it isn't true. And a lot of times they're talking about fiberglass insulation. Here we're looking at the R value per inch of thickness, okay? And here we've got the density in pounds per cubic foot. That's how much it's compressed. And you can see that a lot of fiberglass is installed, from 1 to 2 pounds per square foot or per cubic foot, I'm sorry. And so, you're at a level here where you're at 4.2, but actually if you go up to 3, you're probably at about 4.5 R value per inch. And so you've increased the performance of the fiberglass insulation by compressing it. So you have to think more deeply about, how the density of a material, and a lot of materials are, available in a variety of densities. And so you can, through this chart, you can see what kind of an R value you're getting per inch of thickness. So then there's the effect of humidity, relative humidity on insulation materials. And down here, you've got materials that are fairly, they're not vulnerable. They're not very vulnerable anyhow to high humidities. When you start talking about open cell polyurethane foam, cellulose, and sheep wool. I know we don't use much sheep wool in the US, but the people all over the world have used sheep wool for a long time as insulation. When you get up to, say, into 80%, already you've got more than 20% of the weight of the material is in water and water vapor. But when you get to like 90%, then you've got about 75% of the weight of the material. And, you're getting close to, like, when you get to 100%, now the material is twice as heavy as it used to be. And what that means is it's soaking wet. And so, when we're talking about locations like, say, Wilmington, North Carolina, or, the Oregon coast, or, someplace like Houston, Texas, or something like that, this is for real. The insulation can get seriously damaged and just not be performing at all anymore. So, this is kind of nerdy, but I'm kind of a nerd. All right, then there's these different, what we call barriers. You have a vapor barrier, which you need in a place like Montana, where I live, because otherwise the warm, moist air, the water vapor from the warm, moist air is going to get pushed right through the drywall, and it's going to encounter a cold temperature someplace in the wall, and then it's going to condense, and that's going to cause damage. So we use vapor barriers, but in most places in the US, more mild climates, maybe we'll use a vapor retarder, which lets some of the moisture through and it stops some of it, or it just slows it down, really, is what it does. And but you want the wall or the ceiling to be able to dry to the inside or dry to the outside, because in the wintertime, the moisture wants to go through from the inside to the outside. But when the summertime, the moisture wants to go from the outside to the inside. So you have to be careful, and there's no easy answer. You got to ask somebody who knows about the climate that you're in as to whether you should have a vapor barrier or a vapor retarder, or just kind of an open wall. Let's see, we've got wall and floor insulation. Brick is really tricky, because you can have a brick structure that's 150 years old, and that brick structure is just about as good as it was when it was built. You take a scratch awl and you start poking at the mortar and stuff, and you realize the mortar's still hard. This building is just very, very similar to when it was built. So then what do you want to do with it? It's cold in the winter and it's hot in the summer after the springtime goes. And do you want to really install any insulation on that wall? And I can't answer that question. I know that there's some brick buildings where if you took a scratch awl and put it into the mortar joint, you could push it all the way through the mortar joint. I mean, there's hardly any connection there between one brick and another. And that's the kind of building, in terms of renovation, in terms of energy retrofit, I would be very, very careful, dealing with a building like that. We had a earthquake in Helena in 1935, and it basically stripped brick veneer off of most of the buildings that had brick veneer. The brick veneer just fell off. And brick veneer, really old brick veneer, it has a tendency not to be very well connected to the wood frame building. And I know a crew that was putting steel siding on top of brick veneer, and they went to lunch, and when they came back, the brick veneer had collapsed, and it was really lucky that they weren't there. So be careful with brick. There's a lot of things you can do with brick, but you need a masonry expert to talk to talk about what plans you could have to make it a more efficient building. Here's blown-in insulation. It's a good way to insulate floors, especially if they have trusses, because you can, get through the truss. And these things are what I call, I call them insulation retainers. Okay, you fasten them real tight to the members, to the studs, or to the joists, and then you blow through the retainer into the gap. And it's a really, really good way, and it can be a very, very fast way to retrofit insulation. And we can also use these fill tubes to you push them up in the wall, and we can get a good density of fiberglass insulation or cellulose insulation in that wall, so that the insulation won't sag. If the insulation sags, that's a really bad deal, because you get your place insulated. Now it's only partially insulated. If we're insulating, concrete blocks, we can even insulate the cores of the blocks with this open cell foam insulation. It's a foam that you can put into a cavity, and it's a good product. It's very vulnerable to moisture, though. Anytime that a material like a masonry material or something like foam is wet and then it freezes, what happens is you've got all this moisture, you've got this water in the pores of the material, and the water expands and it makes the pores bigger. So every time this freezing happens, you're getting more and more damage to the material. And that's what causes the spalling of bricks sometimes, where the face of the brick kind of falls off. Is you've had a lot of water in there, and it just so happens that there's a freeze up, and it weakens the brick. So that's something we have to think about. So this is a retrofit that I did on a house that I bought and still live in, and I used a polystyrene insulation, and I had the people who sold me the polystyrene carve a groove in the polystyrene so I could put this treated nailer in there, and it just hung out just a little bit because what I did was I put steel siding on there. I love steel siding. I think it's, I have to love something that can last longer than 50 years and, might even last 100 years, and doesn't need painting, and is lightweight. Because so if you're hanging it on insulation, you're not gonna have a problem with it. And this nailer, being a little bit proud of the insulation, gives you a little space in back of the siding. And that's really good. If you have wind-driven rain like we do sometimes, the rain just gets through the siding, no matter what kind of siding you have. That's why you have a water-resistant barrier, against the structural sheathing, is because we know it's going to get through the siding. We know it's going to get through the siding. So you have drainage, and the steel siding and the plastic siding has drip holes in it, that the water will drip out of it. I don't like the plastic siding. It doesn't have a very long lifespan. Here we're using spray foam insulation. We can use it on the outside. We can use it on the inside. Got to cover it up if it's an occupied area. You have to have a ignition barrier or a thermal barrier. And let's see, how am I doing on time? Okay, I'm doing okay. Let's see. Here we're using masonry foam on the inside of the building. And we have something that we don't like very much, and it is not very well known, called thermal bridging. So if we were to put this steel stud right up against this masonry, there'd be a bridge there. I mean, if you could get on the outside of the house and look at it, you could count the studs all the way through the masonry with an infrared scanner. So what we do is we space it out, and we could either put a sheet of foam in here, or we can spray foam behind it. And then we have what we call a thermal break. And the thermal break is something that kind of defeats the thermal bridging. The thermal bridging is very rapid heat transfer. And when we have a thermal break, then it's not as rapid, and it takes care of most of the problem. So here we have the spray foam insulation installed, against the concrete block. And we have here a bunch of stuff. We have insulation fasteners for masonry, for mounting EPS foam or XPS foam, the polystyrene foam. And we have different tools that can shoot these things into the wall and make it easier. But when you insulate a home or a multifamily building or anything with foam on the outside, that is really a good way to insulate, because all the thermal bridging from what's behind the wall, like studs and other things, we've taken care of that to a certain extent by putting a couple inches of foam sheathing on the outside. And we're going to have to do more of that. I think we have this old way of thinking, oh, I'm not going to put foam on the outside of my house, that's too expensive. And I said, well, how would you like keeping your thermostat at about 50 degrees in the wintertime? Would you like that? Because you couldn't afford the fuel. That's where we're at right now. In Europe, in 1 year, in 2022, the cost of natural gas went up by a factor of 4. And you have people in Eastern Europe that are setting their thermostats at 50 degrees or below. You just can't afford, to be any more comfortable than that. And if we want to avoid that, we got to start insulating buildings, and we got to start air sealing buildings. And so that's what this part of the book is all about: insulation and air sealing. So well, let's look at windows. Okay, one thing we need to know about windows is that you have a let's see, I'm going to get this out here. Okay, you have you have 3 choices of insulated glass. Now, an insulated glass unit is a piece of glass that has 2 panes, 3 panes, 4 panes, and the more panes it has, the higher the R value that's there. And so the colder the climate that you have, the more you want your your R value, or the less of a U factor you want, and the more of an R value you have. I mean, why they don't, measure the thermal resistance of glass by the R value like they do with everything else. Instead, they do it with the U factor. And you'll have to figure that out by reading the book, because I'm not going to talk about it right now. Anyways, it's too freaking boring. Anyway, 70% of the solar heat goes through this low E insulated glass if it's the high solar heat gain capacity unit. But you can order minimum or medium solar heat gain coefficient or low solar heat gain coefficient. And I would recommend just going for low solar heat gain coefficient, because remember that it's the solar heat in most areas that heats your house the most. It isn't the difference between the inside temperature and the outside temperature. It's the solar heat that does that. So, if you own a home with a black roof and no shading of the windows in someplace like Austin, Texas, you're in big trouble, because if the power goes out, you're going to have to move out of your house and live in a tent for a while, because the solar heat is going to heat your house to a very high temperature, a temperature you're not going to be able to live with. So we need to start understanding, how to, make it easier for the air conditioners to cool our homes, because we've got a bad problem with our electric grid, and we're going to see a lot of blackouts and brownouts, next summer. So we got to prepare for that, and we have to spread the word on all this stuff. We our energy costs could go up could double or more. I mean, if it tripled in Europe, well, do you think it could double here? So this is the kind of thing we have to alert our customers about, and encourage them to insulate their homes and get good windows and seal all the air leaks. So I have triple pane low E windows with that are the sun blocking type of low E windows. And you would think that I would want to, let the solar heat in the wintertime to partially heat my home. Well, the fact is that up here, the sun is so low in the sky all day long, that's not going to give you much in the way of heat. And so, don't worry about solar heating your home in a really cold climate. I mean, what you want to do is all the temperatures all over the world, and all the latitudes are getting warmer and warmer. So use if you're going to replace windows, use the low E glass that has the lowest solar heat gain coefficient. So let's see. Frame types. So we have the integral frame type and the flush flange. This would be for stucco or any kind of flat surface on the exterior of the building. But this is the most common type we use for replacing windows and building new buildings. But I think the block frame, where you don't have any kind of a flange on it, is probably the most popular type of window worldwide. We do things differently than other people, but let's look at what a block frame window is. Let's say that you're working on a 3-story home, and you don't feel like getting up, on a ladder or a scaffold with a 300-pound, triple pane window and try to install it from the outside. Well, you can install these windows from the inside or from the outside, which is ever more convenient, because here you've got, clips. These are clips, and you put the window in and get it in the right condition, and then you drive screws through the clips. In some cases, you could drive it right through the casing of the window. So this is the most, I would say, the most versatile type of frame you could use in a window. Now, if you want to put insulation on the outside of the building, the easiest way to do that is to have an exterior jamb extension. I mean, a lot of you are probably familiar with an interior jamb extension, which allows you to have a flat surface to nail your trim onto. But these allow you to have, this particular one, which is the one I used on my house, I put 2.5 inches of foam against here, and then I ran the steel siding right into here. No exterior window trim. Why would I want no exterior window trim? Because I think to cut and install window trim, I think it's about $3 a foot. So if you have a lot of window trim, you're spending a lot of money on window trim, and you have to ask, okay, if I'm putting wood window trim on, how much do I like to paint? I don't like to paint at all. There's nothing here that you need to paint. This is a fiberglass frame with baked on enamel, and is likely to last, I don't know, at least 50 years. And then you have the steel siding, that's guaranteed for 50 years. And so then if you have a steel roof and some other components that are non-combustible or at least non-flammable, then you don't have to worry about your house getting set on fire, from a forest fire or some other type of neighborhood-wide fire. I mean, it's not guaranteed to save you, but you're in much, much, much safer condition for your house if you just don't have things like those shingles, what do they call it? I don't know, but they're made out of some flammable material, and they're the most common type of shingles, and they're garbage as far as I'm concerned. They really are, because you put on a steel roof, yeah, it's going to be more expensive. Why is it going to be more expensive? Because it's going to last between 50 and 100 years, and maybe you don't care about that, but the steel's not going to catch on fire. So anyway, sometimes I start ranting and raving about things. Have you noticed that yet? Okay, let's talk about windows. How we can make windows better. We can put an insulated, a quilted window shade on the inside, or you can put a rolling shutter on the outside, which does, good for the window both in the summer and in the winter. But in the summer, this is how the Europeans survive without air conditioning. I mean, most Europeans don't have air conditioning, but they have, some type of a window covering. They have awnings, they have sunscreens, they have, all kinds of shutters and shades, and even they have Venetian blinds that install on the outside of buildings. And as an American, you go and look at that. Why do they have all these shutters and shades and stuff like this? And then you walk into the building, you realize it's 80 degrees in there, but everybody's fine with 80 degrees, or even more, hotter than that. And they kind of think we're a little soft. Okay, films. for existing buildings, you can put these window films on that block solar heat. And it's kind of like hanging wallpaper. I've done it. And, you know, I'm not an expert at installing film by any means. But, you know, the glass in this surrounding area of the glass, it has to be super clean. I mean, it has to be really, really clean. And you just follow the instructions and it's not that big of a deal. And then solar screens are like window screens, and you put them on the outside of the building, and they basically catch all the heat from the sun. And the sun, you know, the sun's heat doesn't get in through the glass because, you know, it's heated up the solar screen instead. This area here used to be a sliding glass door, but the people got tired of, you know, it being so hot in the summer and so cold in the winter. So they instead put this regular glass door, and the glass door has insulated. It has an insulated core here, and then it has a triple pane with low E glass in it. This is at my house also. Then storm windows, you can put them on the inside, you can put them on the outside. And if you order them with the same kind of low E glass that we've been talking about. Okay. Oh, here, double windows. They do this in a lot of hotels. You know, they got when the hotel was built, they put a cheap double pane window in there, or even a single pane window in there. And then when energy costs got more expensive, they put another window a whole lot like it. So you might have anywhere between 2 and 4 different glass surfaces. So, I mean, this is a cheap way to do it because these windows are really cheap. And you see that kind of a window in a lot of mobile homes too, you know, a double window. Okay, let's get into heating. How much time do I have with that? Oh boy, I'm afraid we're not going to be able to get much done. But I wanted you to know the difference between open combustion and sealed combustion, because this can really be confusing. Open combustion is, you know, this is where the fire is, and it's wide open. There's just some, you know, there's just something that allows the air in. And I mean, a good idea is to put it in an isolated room, but that's not often the case. If it is the case, then the air for combustion comes in. But in a sealed combustion unit, then you have the combustion air coming in a sealed pipe, and then you have the products of combustion coming out. And so you don't have any indoor air used as combustion air. And, you know, this is very safe. These newer units are very safe. And you should encourage people to get away from this. They're getting really, really old. And, you know, you've got chimneys that sometimes backdraft and carbon monoxide and all kinds of things to worry about. And we should just be getting rid of them. Okay, let's look at chimneys. I guess you guys probably inspect a lot of chimneys. And, you know, my book has a whole lot of information on chimneys. I wish I had a chance to talk to you about all the different kinds of chimneys and what you can do to save chimneys, and you know, when you should abandon chimneys and all that stuff. That's all in the book. You know, if you come across, you know, from time to time wood stoves, I mean, if you're living in the Northeast, you know, in someplace like Maine, I mean, you're going to come, you know, in contact with them a lot, and you probably know a lot about how they need to be installed, and you're going to have to check the installation to make sure it's safe. Well, my book has the information you need if you only run into them once in a while. And that's what I meant when I said that you can you use it as a reference. You're not going to sit down and read a 430-page technical book just for fun. It's got to have something. It's got to have a lot of stuff in it that's really, really valuable to you and what you do for a living. We haven't gotten to low-cost cooling. I've got to go through there fast. Cool roofs. We're all going to have cool roofs. I'm sorry, and you can coat your existing roof, or you can buy, different types of shingles, but get yourself a cool roof, and shade your roof with trees if you can. Then in the cooler climates, we just open various windows and we experiment with them to see what really works, to get the air really moving through the house, when it's, 50 degrees, 55 degrees, 60 degrees at night, even 65 degrees, you can cool the house. And my wife and I cool our house down to sometimes to 60 degrees. If we know we're entering a heat wave, and we just try to keep it low, and I'd rather deal with the cold than the hot. The temperature in our house has never been more than 78 degrees, and we don't have an air conditioner. Let's see, we talked about awnings, exterior shading, and tropical climates. If there's any of you that go through tropical climates, this is pretty interesting. Okay, this is Cuba, and the people, they'll open these to get the air moving, and then they have ceiling mounted ceiling fans, and they'll just get it moving fast, because a lot of these tropical climates, it's not often they get above 80 degrees, only 80 degrees, 85 degrees. The people are, tolerant of that kind of thing. And so this is what they've got. There's no glass in this window at all. There's no glass at all. Whereas they changed the windows in this one. And the minute they changed the windows, now you have the greenhouse effect. Now the indoors is getting really, really hot. So you need an air conditioner. I mean, the people did fine without the air conditioner before they put the glass on. Interesting, huh? All right. Have we collected any questions? AJ, are you there? Okay, well, I have to wait till he gets back. I got plenty of stuff.
Oh,
Okay.
I'm here. I just had to, I just had to unmute myself. Looks like we do have a question from Frank. He asked, "Can you explain what cold room is and would it apply here?"
Cold room. Well, I've heard of cold rooms. As far as I actually have a cold room in my building, because I have a computers system in there, a number of computers. And so I use a room air conditioner for that. And it dumps all the heat out into my office, but my office is always cool, even in the summertime. But this cold room that I have is usually, I don't know, 60, 65 degrees or something like that. But there's also, I don't know, I think there's a number of different meanings for cold room. But I would say that it's, if you have equipment that, that can't be above, say, 75 degrees, then you need to put the equipment in a cold room. But maybe somebody else has a better answer. Is there any other questions?
And John, while they're getting their questions together, I just want to remind everyone about CE creds and just reminding everyone to manually put those in after the webinar. Our last webinar of the year is going to be next Friday with Ben. He's going to go over part 6 of his 5-part or his 6-part series of SEO, how to use keyword intent on your website content strategy. So make sure you're signing up for that. And then we'll be back in January with business tips for new inspectors with Ben. And it looks like we have another question from Terry. Is doing a blow door test something a home inspector could add to their inspection services?
I think it would be a great thing for a home inspector to add to the services, because there's still not, a lot of people. There's not a lot of competition. In a lot of places, there's no competition. And in the International Energy Conservation Code, if the state has adopted that, or if your local government has adopted that, then they need to do a blower door test for new housing. So you could pick up a lot of business doing blower door tests in new housing. And then, if a person has an air leakage problem, here's how you know if a house is really, really leaky, is if it's really, really dry during the wintertime. If it's really dry during the wintertime and you're getting shocked, by static electricity and stuff like that, that is a really, really leaky house. So you just tell someone, hey, one of your biggest problems is air leakage, and we can measure the air leakage, and we can follow the blower door's guidance by figuring out where the air leakage is and then sealing the air leakage. So you could use it for retrofit, or you could use it for code compliance. And so I would say that's a really good way to expand your business.
And Terry, I'm looking into whether there's certifications or training for that for you. He also asked what type of company would then come in to do the air sealing and repair?
Well, actually, low-income people can get that job done much easier than higher income people, because you have what's called the Weatherization Assistance Program. And I'm sure that some of you are familiar with that, where they go into the worst housing you can find in the whole United States, and almost all those buildings just leak like a sieve, and they're terrible to live in, and so they have blower doors and they do the work. But some of those weatherization providers, they also do work for private citizens who aren't low income. And so I would say, some HVAC contractors are getting into it, and some insulation contractors are getting into it. So you might check with one of those two types of businesses.
John, where can people find your book if they were interested in getting a copy?
Oh, I'm really stupid sometimes. srmi.biz. srmi.biz. You can buy it online. Right now, single copies are $92.50, and by the box of 12, they're like $82, something like that. But you can buy them online. It's easy.
Is it on Amazon?
Well, version 6 is on Amazon. I still have a few boxes of version 6, so that I'm going to wait till Amazon sells out on that, and then I'm going to give number 7 to Amazon. But my company is called Saturn Resource Management. srmi.biz. And if you just Google Saturn resource, will come right up and it'll take you right to the website.